Welcome back. Today we will begin the first of 3 lectures exploring the many forms of memory and what you can do to improve your memory. Now when you think about it, memory is the natural extension of attention and learning that we spoke about last time. We can't use information that we can't recall, but you can't recall what you haven't attended to. The act of memory facilitates the formation and the activation and the retention of circuits that contribute to the brain's optimal functioning. In a way, we are the sum total of the memory we retain. Without memory, we wouldn't know who we were. Take out a photo album. Observe its power to evoke memories that were previously irretrievable. You see things in there that you forgot about, and suddenly it comes back to you because of this picture. Now the new digital cameras make it possible to date each picture, and some even have GPSs, so that you get an exact fix on where you were when you took the picture. Now a diary or a journal can provide similar methods for testing and adding memory. But you know, memory is too important to delegate to our technological tools. Without our memory, we truly don't know who we are, because we can't bind the past and the present, nor provide a launching pad for creating our future. It's our memory that gives our frontal lobes something to work on. Now we have losses of memory in fictional examples, such as the character in Chris Nolan's Memento. If you remember Leonard Shelby, he suffered a profound memory loss. Now that was fiction, but there are also real-life equivalents. There's a famous patient known as H.M. who couldn't form new memories after surgical removal of the hippocampus and parts of the anterior temporal lobes on both sides of his brain. Now we're going to say a lot about the hippocampus as we go on, but it's the entry portal for information to be remembered. If the hippocampus is damaged, we have difficulty forming new memories, as with H.M. Now H.M., actually his real name was Henry Mollison, and he started having seizures when he was 10 years of age. By age 20, he was completely incapacitated. Couldn't work, couldn't form relationships, lived at home with his mother, because at any time he could be felled with one of these horribly sudden, total seizures. At age 27, 1953, he underwent a new operation. Now, not the corpus callosum operation that we talked about last time, where you split the hemispheres by cutting the corpus callosum and winding up with a split brain preparation. This was a different type of surgery. A finger-sized portion of the anterior temporal lobe was removed, containing both hippocampi. Now, after the operation, H.M. seemed to be normal for the first hour or so, and then very unusual things were noticed. He could no longer learn and remember new information for more than a few seconds. In fact, for a time, people thought maybe he was putting them on. They would come in and introduce themselves, and they'd leave and come back, and he wouldn't remember who they were. And this is the way it was for his whole life, actually. After meeting someone new, he couldn't recall meeting them just a few minutes later, and he had to be reintroduced. It was so bad at one time that he actually, after his mother had died, they said, well, please don't tell him that, because each time someone mentions it to him, he grieves again because he doesn't remember that this occurred. He remembered things clearly that had happened before the operation, but he couldn't form new memories of things after the operation. This included names, events, places. All these were forgotten almost immediately. And over the years, his face in a mirror surprised him, because he only remembered what he looked like as a young man. Every question was new, even if asked moments before. Now, in 1993, his psychologist played a tape for me that I was doing a book at the time on memory. This was a conversation she had with H.M. Now, he had no memory of what he did early in the day or anybody he had met that day. He wasn't certain of his identity, or of her identity, I should say. even though she had worked with him for 25 years. When she told him he should know who she was, he kind of got a little bit reticent, and he said, "Well, I think you and I went to high school together." Now, throughout this discussion of the tape that I was hearing, he sounded very tentative. He wasn't convinced of her assertions or what she was asking him. What he said, he didn't sound like he was very clear about. Finally, with fatigued resignation, he admitted that his memory was severely deficient. Now, H.M. died on December 2nd, 2008, at the age of 82. Since then, his brain has been dissected and converted into high-resolution digital images. Jacopo Anisi, who is doing this, describes it as a neurological biography that survives in glass and pixels. Now, H.M.'s tragic experience led to the new insight that memory is controlled by a key region, the hippocampus, which regulates the inward flow of information prior to its distribution to the rest of the brain, where it becomes long-term memory. Now, memory forms the basis of personal identity, as illustrated by H.M. It forms the basis for it. Memory is also key to thinking. The art of remembering is the art of thinking, as William James put it many years ago. He was one of the foremost psychologists of the 19th and early 20th centuries. Memory involves chemical and structural changes as well. I'm thinking now of the Nobel Prize-winning Eric Kandel's work on aplesia. Aplesia is the so-called sea slug, and when the gill is touched or poked, the gill tends to retract. And the more it's poked, the more this particular reflex comes out. So repetition favors memory consolidation. And of course, that goes all the way up to our own species. Consolidation is favored by repetition. That's why we study. There's also neurotransmitter concentration changes. Neurons grow and form new synaptic terminals. So we have both anatomical and biochemical changes. New proteins are needed to produce these changes, and new connections are made, the synapses. If the repetition of the experience is decreased, the number of synapses also decreases. So there's a relationship there between stimulation, chemistry, and anatomy. The bottom line is that synapses are not fixed but change with learning. We discussed this in Lecture 2 on plasticity. Memory encoding also involves molecular changes within the neurons. But short-term memories involve more than simply the transmission between one neuron and another. This particular neurotransmitter called glutamate is altered, but also there are interneurons that produce serotonin, which sort of tune the release of the neurotransmitter glutamate. Now, this fine-tuning occurs through a series of cascading molecular signals that eventually lead to the modification of the cell nucleus of the neuron. So you're actually changing the genetics of the neuron through these experiences. Another example of plasticity we talked about before. Now, if the changes delve right into the neuron as they do, then you're going to change the whole structure of the neuron in terms of its biology and biological destiny. Now, memories are thus the result of an elaborate process involving chemical and genetic signals that result in new synaptic terminals. Eric Kandel has talked about this. In fact, there's a quote that I'd like to read from him about this. He said, "Short-term memory produces changes in the function of the synapse, strengthening or weakening pre-existing conditions. Long-term memory requires anatomical changes." So unlike computer memory, the brain is always in a state of renewal. Memory is also influenced by emotions, which have different valences according to the situation. If I asked you to remember September 11th, it's not just a date, it's a specific event which occurred September 11th, 2001. If you're old enough, try to remember where you were and what you were doing when you heard about the death of JFK, John Fitzgerald Kennedy. So you see, recalling a memory restarts the process of consolidation. It involves emotions as well. It starts again as a short-term memory, and then proteins are produced for consolidation to form long-term memory. Thus, remembering is a creative act that can't be duplicated by a computer. Joseph Ledoux has done a lot of research on memory, and he has a good quote regarding that. As he puts it, the brain that does the remembering is not the brain that formed the initial memory. In order for the old memory to make sense in the current brain, the memory has to be updated. It's almost Proustian in a way, the idea that your personality is changing as time goes on because of memory. Now, this has important implications for our new understanding of memory. The Greek philosopher Heraclitus said you can't enter the same river twice, meaning it's always changing, it's not the same. You also can't remember the same experience exactly alike on different occasions. The you of today, in other words, is different from the you who was present very short time ago, who remembered and earlier consolidated a memory. So with this as background, let's return to the hippocampus, the starting point for all the memories as we have seen with HM. Hippocampal disease is always accompanied by disturbances in memory. Alzheimer's is probably the most frequently attributed disease that we talk about. Mild hippocampal atrophy also occurs in depression. And as depression gets better through antidepressants, you begin to see normalizing of the size of the hippocampus as memory normalizes. I use a test with patients. I give them like 4 items to remember, like apple, pen, tie, house, car, 4 or 5, and ask them to repeat them and then see if they can remember them 5 or 10 minutes later, which is a test of encoding within the hippocampus. Now, the recollection of the past and imagining the future functioning are also part of the hippocampus. Imagining a future event, you have to have some memory of many times a past event, because both memory and imagination are impaired in Alzheimer's disease, which is the extreme loss of memory and, sadly, the loss of self. The physical applications, such as using memory exercises as a means to foster imagination and vice versa, are seen in writing schools, for instance. A young aspiring novelist will be asked to go into a restaurant and listen to a conversation and get the exact way people talk so he can use that later in a novel and form highly specific images and later write them down. Camera can be used. I used a little 15-second clipette. I have a small camera which takes still pictures primarily, but it also takes little movies. I'll take a 15-minute clipette of something and then later look at it and then later try to remember what I saw and then use that to enrich my memory. So why not rely entirely on electronic memory aids? The reason is that this would lead to disuse atrophy. In Plato's Phaedrus, Socrates refers to the Egyptian god Thamus on the invention of writing, which is really very similar to what we're thinking about now when we talk about memory. This invention will produce forgetfulness in the minds of those men who learn it, because they will not practice their memory. Their trust in writing, produced by characters which are not part of themselves, will discourage the use of their own memory within them. So even as far back as that, there was some recognition of the fact that you can't be depending on outside sources of memory. Today, disuse atrophy comes from technology. Nothing has to be remembered. But disuse atrophy can be overcome by deliberate efforts to improve your memory. This helps stave off Alzheimer's. It hones your attentional abilities. It links memory with other cognitive processes such as learning and creativity. There are good and bad memories, as you know. Some people have great memories. You ask them something, they're able to tell you the answer and remember it, tell it to you months later. Other ones have kind of bad memories. The key is retrieval. Retrieval is a distinguishing feature. Memories are best coded and relieved and retrieved when linked with an image or an emotion, the basis for memory techniques that we will cover in Lecture 9. Now, there are many types of memory, but here we'll concentrate on declarative memory. They are consciously accessible memories, and they're also infinite. Vocabulary is a good example. There's no limit to as many words as you can learn, and that's an example of declarative memory. And non-declarative memory is something that really can't be put into words. You riding a bicycle, for instance, is non-declarative memory. Doing a double flip off a diving board is another example. You can't really tell people how to do those things. They've got to learn them by doing them. So all memory techniques are aimed at enhancing declarative memory. What can I do? What do I know? And how could I declare it? Now, inattention is the most common cause of forgetting. As we mentioned, if there's no encoding, there's no retrieving. The number one rule for memory then is pay attention, as we discussed in the last lecture. Of course, attention increases with interest and varies with interest. Increase your areas of interest, you become more attentive. Your memory's better. Even people with ADHD can learn and remember if they're interested in the topic. So take your time. As Milan Kundera says in his novel Slowness, there's a secret bond between slowness and memory, between speed and forgetting. Now let's talk about what some general memory rules are for enhancing your memory. In Lecture 8, we will discover and cover memory techniques and systems to superpower your memory and supercharge it. Over the next few minutes, we will cover how to sharpen sense memory, augment general memory and short-term memory, long-term memory, and working memory. Remember, the most important principle for improving your memory is focusing your attention on what you're trying to learn. That's why I spoke earlier of attention in the previous lecture before we got to memory. Distraction in our time is the basis for information overload and for inattention. You should start with sense memory, because that's the brain's initial recording of the physical sensations as they impinge on our sense organs. It can be iconic memory, what we see, echoic memory, what we hear, and in addition, what we touch, taste, and smell. Too often, our own sensations occur outside of our awareness. So I'm going to suggest exercises that can help you to enhance memory via heightening conscious awareness. There's an example of this in an epigraph of the book The Motorcycle Diaries of Che Guevara, where it stated, "If you can see, look. If you can look, observe." Of course, if you do that, you're paying full attention and you're likely to remember. Jose Saramago, the famous Nobel Prize-winning author, had an uncle who described bulls this way. When he was describing what a bull is like faced with a bullfighter, he stated, "He sees you, and then when he's seen you, he looks at you. And this time there's something different about it. It's because he observes you." So this is an example of paying full attention and remembering, just like the bull is going to remember certain things. A lot of times we go through life without remembering what we're doing. Have you ever noticed that someone will immediately be looking at a watch and a second later you'll ask them, "What time is it?" and they look again? I mean, why would that be? Didn't they just look? Don't they remember exactly what they saw? So it's an example of the fact that we are not paying, quote, attention to our sensory input. Now here are some exercises to sharpen the special senses of taste and smell. You recall in the earlier lecture, we went over the sensory exercises for vision and hearing, hand dexterity, and peripersonal space. Here we're going to take up exercises for the special senses of taste and smell. Let's start off by taking a number of spices at random and setting them out on a table. Close your eyes and identify by smell alone such things as oregano, mint, minced onion, sage, sweet basil, orange, cumin, black pepper, a whole array. Olfactory sensory fibers, by the way, connect directly to the brain. There's no intermediary. It doesn't go through the thalamus. This is why it's the most direct part of sensory input. Now combine this knowledge with identifying spices in a meal that you're eating. Ask the cook, what did they put in? If you're in a restaurant, try to find out. When you're making a meal with the spices, try not putting the spices in a certain part of the meal. certain half of it. Do you taste the difference? Of course you do. Cooking, in fact, is one of the best ways of enhancing your sensory memory, along with other things like general episodic memory and frontal lobe. This is really the real example of frontal lobe, coordinating things so they come out just right, just like the CEO of the kitchen, if you will, just so everything is ready on time. The older you are, the more difficult it is to learn to cook, but start wherever. I started cooking only 10 years ago, and I'm certainly not a chef, but I think I can make a decent meal. Now, memory is short-term and long-term memory. Short-term memory is maintained through active rehearsal. Keep going back over something. It eventually gets into long-term memory, and you have the storage of information. Every day of our lives, we strengthen this through active efforts to learn new information through reading or taking courses like this one. So a powerful short-term memory strengthening exercise would be simple exercise that's a predictor of math, reading proficiency, attention, concentration, sequencing, and auditory and visual short-term memory. It's called the digit span exercise. We'll do it first with auditory recall. Read into a voice recorder a series of 5, 6, 7, and 8-digit strings. You'll probably want to group them so that all of the 5-digit strings are together, the 6 digits together, and so on. Now put them aside for a while and clear your mind. Several hours later, listen to the lists again, pause, and write down as many of those strings as you can recall. Then play the recording to check your accuracy. You can do this visually by writing those lists on a piece of paper. Write the lists, turn them face down, look at them quickly one at a time, and then try to remember the sequences you saw. You can check at the end by turning them face up again. Now there's benefits from doing both visual and auditory span. First of all, it's a quick test of whether you're a visual or an auditory learner. It focuses attention and it focuses concentration. And digit span can be increased by practice. You start at 5 and work your way up. A normal adult digit span is between 5 and 7. It's very interesting that one number per year of age is normal, starting at about 3. So a 2-year-old can remember 2, a 3-year-old can remember 3, etc. And the average digit span of an adult, in other words, is that of a 7-year-old child. So you have to work on it to build it up. The important principle is chunking, from a paper called The Magic Number 7 plus or minus 2 by George Miller, who was a Princeton psychologist. He found that if you chunk the numbers so that you could actually put them in a meaningful, you could take a long string, you could break them up into parts. That's what we do when we remember a telephone number. We remember the first 3, then we have a space, and then we remember the last 4 numbers. Now the brain doesn't spontaneously encode into short-term memory more than 7 items, so if you want to improve your digit span, you have to practice it. But why bother to practice and lengthen digit span, you might ask? Seems trivial, doesn't it? But it's not something that, well, of course it's not something that most of us do. But what's happening is that the digit span is a predictor of math and reading, enhanced performance in attention, concentration, sequencing, and auditory and visual short-term memory. So don't be fooled by the apparent simplicity of this exercise. This is a powerful way of improving brain function in multiple areas. Short-term memory now needs to be actively rehearsed in order to move it into long-term memory. Attention must be focused on the material. If attention is disrupted by a distraction, it's like when someone asks you a question, then we lose the track of it. But rehearsal alone isn't sufficient. Depth of processing is required. Rote repetition is not as effective as working with the information. Memorization of dates, for instance, is not as good as writing an essay having to do with what happened on that particular date. Depth of processing increases the web of connections among the stored memories. So in other words, it increases those neuronal connections that we've talked about throughout these lectures. There's also an importance of repeated testing. The test should include old as well as new material. For instance, you remember those ornery professors from college who you unexpectedly would subject you to a pop quiz. Most annoying of all were those who went back and retested you on things you had already been tested on. You'd say, "Prof, we've gone through all that before." Well, it turns out those profs were right. They were onto something. Repeated testing is more effective for long-term learning than additional study. I want to repeat that. Repeated testing is more effective for long-term learning than additional study. That's from research done by Jeffrey Karpik and Henry Roediger at Purdue University and described first in Science. So practicing retrieval during tests results in greater learning than studying alone. So it's better to go back and retest than it is to just keep studying the same things over and over. Even after the item has been learned, the best way of remembering it is by retesting. Why? Well, the neuronal networks, called cell assemblies by the Canadian psychologist Donald Hebb, are strengthened each time the memory is retrieved. It's really similar to physical training when you think about it. After you build up a muscle or a muscle group, you have to keep exercising it or it will undergo the disuse atrophy that we talked about earlier. Similar things have been found in my own field of neurology. I teach medical students, they remember more about neurological illnesses when they're repeatedly tested rather than the usual sequence of learning it, jamming it in overnight, and so forth. And that's the way it should be, because as a neurologist, they don't know when they're going to see a certain thing, so they don't just learn a certain disease and then sort of forget about it because they have to go on to other things. It has to be part of their permanent repertoire. And the only way to do that is to be retested on it. And of course, as patients come in with these illnesses over the years, that's the form of retesting, if you will, that they'll be exposed to. Similar results. Short-term memory is often sufficient to just rehearse a phone number, dial it, and forget it. Any storage of information you may want to mull over, manipulate it, you have to do so. You put it in your mind. You mentally rehearse the terms, for instance, the items on a grocery list. You compare them to what you remember you have in your cabinets at home. So that's memory, but it's a special kind of memory. It's called working memory. It's when you manipulate information in your memory, you're using a special form of memory. You're not just going back and linking things up one before another, but you're moving them around. So if I ask you a certain thing like name all the players in your favorite baseball team, you name them, that's general memory. But if I ask you to, well, give them to me by what position they're in, or if I say to you, give them to me by who came on the team first, these sorts of things, then that's working memory. So from our discussion in this lecture of general memory, we're going to move on in our next lecture to this most important memory process of all, the working memory, which, as I'm going to mention to you, is so important that we can say that it is probably the most important element to keep sharp throughout our lifespan in order to optimize brain function. Thank you.